Okay, here we've got a clue solving problem where they give us one clue at a time and we have to work out the answer to the main question is which cylinder, A or B, has the largest volume. And we've got 6 clues, and we have to take clue 1 first, clue 2 first, etc., etc. And then we have to try and work out how many clues do we need to work out which cylinder is largest. And then we use the other clues to maybe find out more about the question itself, or check that we've got everything right. So the first clue that we have here is clue 1. For the base of cylinder A, there is a diameter of 20 centimetres. 20 centimetres, okay, well that gives us then our radius of 10 centimetres. Is that enough information to say which of the cylinders is largest in volume? No. So we're going to need clue 2 as well. Then it says clue 2. The base of cylinder B has a diameter of 10 centimetres. Well, now we know something about cylinder B. We have a diameter of 10 centimetres, which means that we will get a radius here of 5 centimetres. So we know that the radius of cylinder A is 10 centimetres and the radius of cylinder B is 5 centimetres. Is that enough to tell us anything about the volume? No, because if we don't know the height of the cylinders or the relationship between the height of the cylinders, we can't do anything to check the volume. So we're going to need clue 3 as well. Clue 3 is that the height of cylinder B is 4 times larger than the height of cylinder A. Now we have a relationship. So now that we know that if this height is the height of cylinder A, we know that this height, which is cylinder B's height, is the same as 4 times the height of cylinder A. This should be enough now to actually work out which of the cylinders has the larger volume. So let's use our formulas. The volume of cylinder A, we know, is the area of the base, which is pi times the radius of A squared, multiplied by the height of cylinder A. And notice I'm using RA here, means the radius of cylinder A, H. So we'd better actually define some terms. We haven't defined any terms yet. So let's do that. VA is volume cylinder A. RA is radius cylinder A. And that's in centimetres. And the H is the height of cylinder A. So we'd better calculate that in centimetres as well. This will give us a volume of cylinder A in centimetres cubed. Radius squared will be centimetres squared times centimetres. So all our units are the same. So now we have our terms that we need for cylinder A. And for cylinder B, VB, well, let's actually just write it underneath here. VB is going to be the volume of cylinder B in centimetres cubed. RB is going to be the radius of cylinder B in centimetres. And HB is going to be the height of cylinder B in centimetres. So it doesn't take long to define our terms, but it does mean that now we can use formulas throughout because we've defined what all of these letters mean in the beginning of our question. Okay, so if we know that the volume of A is pi r squared times H, we actually know that the radius of A is 10 centimetres. So let's put some numbers in here now. Volume of A is going to be 10 squared times pi times HA, which is going to be 100 pi times HA. Let's look at volume of cylinder B then. Well, the volume of cylinder B is going to be pi times the radius of B squared multiplied by the height of b, which is going to be pi times the radius squared. We know it's 5 squared. The radius is 5, so the radius squared is 5 squared times hb, which is going to be 25 times pi times hb. But we know something about hb. We know that hb is 4 times ha, so we could replace hb here with the ha term that we have up here. So let's say that replace hb with ha, it equals 4 times ha. Now this is quite useful because it means that we have the volume b and the volume a in terms of the same thing. Here we have pi and ha, and here we have pi and ha. 25 times 4 is 100, so we have 100 pi times ha. So we know that the volume of b is 100 pi ha, but the volume of a is 100 pi ha. We don't know what the height is, but we don't need to. We can see that the volume of A and the volume of B are totally identical. They have all the same terms in. Here's 100, here's 100. Here's times pi, here's times pi. Here's times HA, here's times HA. So these volumes are identical. So therefore, after clue 3, we know that volume A equals volume B. So we have solved this question after clue 3. But let's see if what we can do with clue 4. Do we need clue 4 at all? Clue 4 is that the base area of cylinder A is 4 times as large as that of cylinder B. Well, we actually haven't done very much on areas, but let's have a look at what happens for cylinder A. We'll use a different colour here, makes it a little bit clearer that we're now talking about volume. The area of A will be pi r of A squared, which will be pi and the radius squared, 10 squared. So 10 squared is 100. The area, and this will be centimetres squared, the area of cylinder, the bottom of cylinder A will be 100 pi. The area of the bottom of cylinder B will be pi times rb squared, which will be pi times 5 squared, which is 25 pi. So the area of cylinder B is 25 pi, and the area of the base of cylinder A is 100 pi. So yes, we can see that the relationship here is 4 times larger. 25 times 4 would give us 100 pi. 25 pi times 4 would give us 100 pi. So we can see that relation. So we didn't need clue 4. It doesn't help us at all, and we could have worked it out with the information that we got from clue 1 and clue 2. So clue 4 was unnecessary. What else do we have then in clue 5? Now clue 5 is an interesting clue because clue 5 allows us to calculate the height. Clue 5 says the volume of cylinder A is 8,000 pi. So volume of cylinder A, clue 5, volume of cylinder A is 8,000 pi. But that must mean that the volume of cylinder B is also 8,000 pi, because we've worked out that they have the same volume. So now we must be able to work out the height of both of our cylinders. So let's make a little bit of space here. We don't need the area calculations, but we can carry on from the part we have here. We know that the volume of cylinder A can be expressed in terms of 100 pi times HA, and that unit is centimetres cubed. But we also know that the volume of cylinder A is 8,000 pi centimetres cubed. So now that we know everything except h, we don't know what the height is. So let's divide both sides of our equation by 100 pi. We have 100 pi times h here, HA. We want HA by itself. If we divide both sides by 100 pi, we'll get h by itself. So 100 pi times HA divided by 100 pi equals 8,000 pi divided by 100 pi. What happens then? Well, 100 pi cancels with 100 pi. 100 pi divided by 100 pi would be 1. Pi divided by pi would also be 1. We can cancel this 0 with that 0 and divide the top by 100. So we get that HA, and here we would have units here of centimetres cubed, and the unit of this area part here will be centimetres squared. So we have units of centimetres cubed, the volume, divided by the area part, centimetres squared, giving us a height to HA of 80 centimetres. The units here would be, this is the area part, so HA would be in centimetres. So we now know that the height of cylinder A is 80 centimetres. Can we work out the height of cylinder B then? Well, yes, because we know that the height of cylinder B is 4 times the height of HA. So the height of B would be 4 times 80, which would be 320 centimetres. If this is correct, and we always like to do extra checks, if this is correct, if we put in all of these terms, we should get that the volume of cylinder B is 8,000 pi. Well, let's do it. The volume of cylinder B is pi times the radius squared, which is 25, 5 squared is 25, times 320. And if we multiply, let's think of that as being 25, we can think of that as being 100 divided by 4. Why am I doing that? Because I really don't want to have to multiply by 25. I'd like to make it as easy for myself as possible. 25 is the same as 100 divided by 4. 320 multiplied by 100 would be 32,000 divided by 4 times pi. 4s into 32 go 8 times, so we would get 8,000 pi. So we've proved to ourselves using our the actual values that we got that yes, we would end up with a volume of 8,000 pi if we had a radius of the cylinder of 5 centimetres and a height of the cylinder of 320 centimetres. So now we've sort of double checked clue 5 as well. And the last clue that we have in clue 6 is that the volume of the cylinder can be expressed as pi times 10 times 10 times 80. Pi, the volume of B can be expressed as pi times 10 times 10 times 80. Well, it can be expressed as anything like that because we know that the volume of cylinder B is 8,000 pi. 80 times 10 times 10 times pi. So it's basically giving us the same information as clue 5 gave us. So clue 6 is also unnecessary. It's the same information that the volume of the cylinder A and B, we know they're the same, we know that they're already equivalent to 8,000 pi. So we didn't really need that, but this is how I'd like it to look in your books, making sure that you've got formulas, making sure that your units are complete, that your checks of units are correct all the way through, and solve this type of problem solving one step at a time, yeah, something like this in your book. Sketches, formulas, calculations, proofs, discussions.